6 nights, same empty coordinates, same impossible radio pulse. Then archivists checked old images and found something worse. A lunar crater seemed to change shape between frames, not over centuries, between exposures. So what did Tenerife actually catch? A distant signal, a local reflection, or a geometry trap? This is not a ghost story from a telescope dome. It is a chain of small, physical possibilities. Each one sounds harmless alone. Together, they turn one quiet sky position into a puzzle. First comes the signal, then the crater, then the question nobody likes asking. What if the sky stayed still, but our viewpoint cheated? Start with the observatory itself. Tenerife sits high above clouds in the Canary Islands. That matters more than the mystery. Dry air, dark skies, and stable seeing reduce interference. Astronomers build there for a reason. A good sight removes excuses, so 6 repeated detections become harder to dismiss quickly. Not proof, but pressure. Random noise can appear once. Bad luck can happen twice. By night 6, patterns start demanding a mechanism. Now picture the signal. Not a voice, not coded words, just energy arriving from one narrow sky position. That already narrows the suspects. Wide noise usually smears across frequencies or direction. A persistent point suggests alignment. Either something truly emits there, or something redirects there. And redirection can be sneaky. A telescope can be honest, while the path is not. The sky can lie without moving at all. Radio astronomy lives with that danger constantly. Signals bounce, leak, scatter, and masquerade. Aircraft, satellites, distant transmitters, and even electronics can intrude. Some enter through side lobes, not the main beam. The dish seems aimed at emptiness. The contamination arrives from somewhere else entirely. That creates the first twist. An empty point in the sky may never be empty. It may be a mirror position created by the instrument, and mirror positions can repeat for several nights. Why several nights in a row? Because Earth rotates, but not randomly. Observatories revisit similar geometries each night. A source below the horizon can line up with hardware similarly. A satellite path can recur near the same local time. Ground interference can strengthen when temperature changes after sunset. Even tiny thermal warping matters. Metal expands by day, contracts by night. That can shift sensitivity just enough. A false source may appear punctual. Predictable falsehood is more dangerous than obvious chaos. There is another possibility. The signal may have been real, but not from deep space. Objects in Earth orbit can reflect radio waves, so can space debris. A dead satellite does not need to transmit actively. Under the right geometry, it can flash borrowed energy for seconds or longer. If the reflection repeats across nights, suspicion drifts upward, not to aliens, to orbital traffic and timing. Modern skies are crowded, even when they look clean. But the crater makes this harder. A weird signal is one problem. The temptation is to fuse them instantly. Same week, same observatory, same mystery. Human brains adore one grand explanation. Science survives by resisting that urge. The crater may connect. It may also be a separate artifact uncovered by panic. Sometimes the second anomaly appears because people start searching harder, and archives always hide strange-looking frames. So how can a lunar crater change shape between images, usually without moving at all? The moon has no weather to erode it overnight. No visible process redraws crater rims between quick exposures. If shape changes appear, think light first, then think angle, then think image processing. Only after that should you think impact, and impacts large enough to alter a crater visibly are rare enough that other instruments would likely notice. The moon is brutally deceptive under low sun angles. Tiny shadows create giant visual differences. A rim looks sharp, then broken. A floor looks smooth, then split. 1 degree of illumination can redraw the scene. This is why lunar observers revisit features repeatedly, not because the landscape changes fast, because sunlight edits the relief dramatically. A crater is not just stone, it is stone plus shadow. Change the shadow and the brain invents movement. Now add camera differences. Archive images often come from different nights, sensors, and compression. Stacking methods can sharpen edges unevenly. Noise reduction can erase faint ridges. A slightly misregistered frame can make a rim bulge. Overexposure washes bright walls outward. Underexposure deepens inner darkness. This happens constantly in planetary imaging. Most people never notice because they compare one photo, not many. Archivists do, and that is where oddities breed. There is also libration. The moon does not show exactly the same face each night. It rocks slightly because of orbital geometry. That tiny wobble changes perspective. Features near the limb distort most. Circular craters can look oval. Inner peaks can appear, vanish, then reappear. Even central shadows slide. A stable landscape presents a moving portrait. To an untrained eye, it feels impossible. To lunar mappers, it is routine. But routine effects can still trigger extraordinary misunderstandings. So why did anyone care enough to cross-check old frames? Because 6 nights is annoying. Repeated annoyance turns into investigation. When one anomaly persists, technicians start checking everything nearby. Pointing logs, clock sync, weather records, hardware temperatures, software updates, and image archives. That is where coincidence can become a trap. A separate visual oddity suddenly looks linked. The mind builds a bridge before the data does. Once that happens, every detail starts leaning toward drama. Still, let us test the strongest connection. Could the moon itself have caused the radio signal? Directly, not likely in any mysterious way. The moon reflects radio waves. It is not radio silent. Radar experiments have used that for decades. But a reflected lunar signal usually follows geometry and known frequencies. Unless the telescope geometry was misread, then a lunar reflection could seem displaced. Not impossible, just technically embarrassing. And technical embarrassment is common fuel for cosmic legends. A displaced source can happen through side-lobe pickup. Think of the main beam as the spotlight. Side lobes are dimmer, unwanted flashlights around it. A bright object outside the center can leak in. If the moon sat in one of those sensitivity wings, trouble starts. The recorded position may shift away from the real object. On paper, the signal comes from emptiness. In reality, the instrument heard the moon indirectly. That would also explain repetition. Lunar position changes predictably, so did the telescope's blind spots. The moon away there, the moon feels remote. Instrumentally, it can still be a nuisance neighbor. It is bright, moving, and geometrically powerful. Its presence can affect observations even when not centered, and its visual appearance changes nightly. That creates a tempting narrative bridge. Signal weirdness plus crater weirdness. One body, 2 anomalies. But the bridge only holds if timings align. Were the radio detections made with the moon nearby? Were the crater frames captured under comparable conditions? Without that, the mystery splits again. Another hidden suspect is software. Modern observatories depend on pipelines. Raw data becomes calibrated data through layers of correction. Bad metadata can shift coordinates. A timestamp error can move a target. A pointing model bug can mislabel a field. An image registration glitch can distort lunar comparisons. None of this is glamorous. All of it is powerful. People imagine one giant failure. Reality prefers several tiny ones. A minor clock offset plus a side lobe reflection plus aggressive sharpening. Suddenly, the impossible becomes ordinary, but only after painful analysis. Now consider a more physical twist. What if the crater really changed appearance because something struck nearby? Small impacts happen on the moon. Observers have seen brief impact flashes before. Fresh ejecta can brighten local terrain. Dust can alter contrast around a feature, but visibly changing the silhouette of a known crater between normal archive frames, that asks for more energy. Enough energy leaves broader evidence. Other telescopes would compare before and after images quickly. The moon is watched too often for large changes to stay secret. So impact remains possible, but weak. There is a stranger optical effect too. Earth's atmosphere can distort lunar edges in bursts. During poor seeing, details boil and deform. If an archive selected the sharpest frame from one session and a softer composite from another, shapes can disagree badly. This is especially nasty near terminator shadows. A wall edge looks notched. The crater did not mutate, the air did. An observatory can sit above many clouds and still fight turbulence. High altitude helps. It does not grant perfect truth. What about the signal source being astrophysical after all? That remains on the table. Transient radio sources exist. Some flare, vanish, then return. Pulsars, magnetically active stars, and exotic bursts complicate the sky. But the phrase empty coordinates can mislead. A spot may look blank in visible light, yet host something faint. Dust can hide objects. Distance can dim them beyond old surveys. Radio telescopes often discover what optical archives missed. So the signal could be real, while the crater mystery stays unrelated. That answer feels less dramatic. It is also scientifically respectable. The real tension comes from timing. 6 nights create confidence. Archive anomalies create narrative gravity. Put them together, and people start seeing one machine. But nature often works through overlap, not intention. A recurring radio source can coexist with a misleading moon image. A suspicious crater can coexist with instrument contamination. The hardest part is emotional, not technical. Can you let 2 eerie things remain separate? Most minds would rather force a single cause. This is why observatories keep logs obsessively. Not because scientists distrust the sky, because they distrust appearances. What was the humidity? Which receiver chain was active? Did the telescope slew near the moon earlier? Was a satellite pass predicted? Were identical settings used in both lunar images? A mystery shrinks when context grows. Often the decisive clue is boring. A maintenance note, a firmware change, a calibration lamp behaving badly. The universe rarely owes us theatrical explanations, yet some puzzles survive that grind. Not because they break physics, because data arrives incomplete. An archive frame lacks raw files. A signal falls below confidence after reprocessing. A weather record is missing. A side-lobe model remains uncertain. Then the story freezes in a half-open state. Not proven, not gone. Those are the cases people remember. Not full discoveries, not full mistakes. Just unresolved intersections where instrument, sky, and timing nearly impersonate a revelation. So what most likely happened over Tenerife? The safest answer is layered. A repeating radio anomaly probably came from geometry, interference, or a real transient. The crater shape shift probably came from illumination, libration, or processing. Their collision created the legend. But legends start somewhere useful. They force harder checks. They expose blind spots in instruments and in perception. And they remind us that astronomy is not only about distance,